What would you want a prospective physics major to know about the discipline?
Okay, so physics is about how the world around us works, how the universe works, all the way from galaxies to ordinary things like apples falling down. So it really you by learning physics, you understand the basic principles, underlying principles, and about how things work, from electricity to motion to the world of atoms and molecules. So it's a foundational science, and it provides foundations for all other sciences. The language of physics is math. So physics uses math as its language, and then chemistry is derived from physics. Even biological, there are added complications when you go to chemistry and biology, but physics is a foundational science. It is also nowadays getting very interdisciplinary. So what is interesting about physics, what makes it special, is that not only do you understand how the world around you works, if you're curious about it, but understanding the concepts of physics allows you to also address problems in other disciplines, because these are deep concepts which have implications in many other cases. So right now, for example, physicists are looking at problems in computer science using ideas from physics. In biology, so it's also very interdisciplinary these days.
hmm And what makes the field of physics so special to you personally?
Well, because I'm so personally, I'm fascinated by the idea that by this combination of observations, experiments that people do, and by pure thought, you are able to divine the laws of the universe. I mean, Einstein was able to, by pure thought, Maxwell was by pure thought, they were able to uh, look at all the available data and then come up with a theory that explained everything, from something that's universal. And the fact that you can do it is just astounding,
hmm
actually. So that is a very fascinating thing. It's a very deep um, subject, which nevertheless, is connected to the real world. So mathematics also, I'm drawn to mathematics, abstract mathematics. But mathematics, very abstract, sometimes feels a bit disconnected from the real world. It's about truth. Physics, is also very abstract, universal, but also connected to the real world. So you can explain very deep, mathematical ideas, but also very mundane things like this object dropping.
Yeah.
What happens, uh, and it's very practical. I mean, pretty much everything that all the wonderful things that you see around you, all the technology, all the this would not have been possible if we had physicists have not uncovered the laws of quantum mechanics. The
hmm
computers, everything really is drawn from these basic disciplines of quantum mechanics, electricity and magnetism, statistical physics. So it is transformative, it is deep, foundational, and it applies to the real world around you. It helps you make sense. What more can you ask for?
hmm Yeah. And what kinds of careers and or graduate programs can a physics major pursue?
So again, given the wide range of things physics is applicable to, there are a wide range of options. One option for students who are very fascinated and want to pursue higher studies is to go to graduate school and pursue a master's or a PhD in physics. But many students then choose to, just stop at the undergraduate after the undergrad and go on to the job market. And what makes physics major valuable for industry when students choose to do that is that they know that physics is a hard subject. It's a very difficult subject because you have to have abstract thinking combined with mathematical abilities and then practical problem solving skills. So when you do a physics degree, they know that you are very good at understanding from first principles and at problem solving. So that is a key important, very important criteria. You also will have exposure in the physics major to experiments. So you'll do a lot of experimental work. You will know how to operate specialized equipments, and you will do computational work as well. So you will be good with the computer. You will learn programming, and you will be able to apply it to problem
hmm
solving. So the primary reason industry is interested in physics majors, I would say, is that they are known to be very good problem solvers. Physics teaches you how to model things how to solve a problem, how to reason from first principles, because that's again in many
Yeah.
cases when you try to find answers to problems, you can go wrong if there are multiple avenues. But physics teaches
Hmm.
you how to start from principles that you know, and based on that, reach make deductions and reach answers. So all of these skills are implicit in a when you do a physics major, and so that's I think one of the reasons very valued. So students go on to diverse things. They can go on to banking, finance, where they can do problem solving there, or they can go to patent law because you understand the basic physics. And so there are many diverse options. Of course, the tech industry is very
Hmm.
a big employer here. So
Of
biotech is
course.
another option. We have a very strong biophysics program. Another thing we are excited about is there is a lot of excitement these days about quantum computing. Okay, so
Mm.
classical computers, of course, computing revolution has tremendously transformed our world. But now there is hope that we can actually exploit the properties of quantum systems to build quantum computers and to use them. They are already being built, or to use them to do things which were not possible before.
Yeah.
So there is a lot of investment by the US government and by private industries in this field of quantum computing. And that is something that we are sorely lacking people who are trained in understanding the basics of quantum information, quantum
Hmm.
computing. So what the physics department here has done is we have developed a quantum information certificate program. And this is a set of 4 courses that students can do
Hmm.
as part of their undergraduate major in physics. Um, and they would get on top of the major, they would get a certificate. And certificate would be a quantum information certificate, which would teach them the basics of quantum information and quantum computing to the extent that they can then, enter the job market in this very exciting field.
Hmm.
Uh, Many of the companies working in this are located in Boston, so that's very convenient as well.
Yeah, absolutely.
Yeah, so it's a range of things, which
Hmm.
based on your abilities for problem solving and computing, and specialized fields like quantum information, machine learning,
Hmm.
AI, are also facing
Hmm.
this.
And what research opportunities are available in the physics department at UMass Boston?
So I want to preface this by saying that we are a very research-friendly department. We strongly encourage, undergraduates who are interested in research, that they should talk to their faculty advisor, to their mentor, and seek out. Anybody who's interested in research can even come to me personally, and I will try to do my best to, connect the student with a faculty mentor who may be interested in
Hmm.
guiding them. We've had several, wonderful outcomes based on student research in the past years. Uh, 2 of our students have received the highest award for an undergraduate, which is the Goldwater Scholarship, one of the most prestigious awards for
Oh,
undergraduates. So 2 students in the last 3 or 4 years, I think, have received this Goldwater Scholarship, which is quite remarkable because a
yeah.
university does not get to nominate more than 4 Goldwater scholars every day, the whole
Oh,
university,
wow.
right? And
Hmm.
out of those 4, sometimes you get 1 or 2 basically every year.
Hmm.
So for physics, just as a department to have 2 over the span of 3 years, actually it was, and we have one more who
Yeah.
have nominated this year. We are hopeful about. So
Hmm.
so that just speaks to how much they invest in the department is in making sure that students who are interested in research are well prepared and are competing for prestigious national awards and
Hmm.
internships. Students have gone into internships. So I should also add that Joseph Ferra, who was one of our undergraduate students, is now a graduate student at in California, UC Santa Barbara. He won the Leroy Apker Award, which is the top award given for research for an undergraduate researcher in physics across the US. So, he's competing with students at Harvard, MIT, Stanford, everywhere. He was the top student selected, right? So, I think
Hmm.
we're very proud of what Joseph has done, and again, he was very happy with.
Yeah.
So I would say that we are a young department with a lot of research activity. Um, our faculty are well funded and
Hmm.
very active in research. So there are plenty of research opportunities. And not only that, the department encourages this and will be supportive of research, your research progress throughout. As is seen by all of these awards that the students got, they got them because we
Hmm.
nominated them for these awards, right? That's part of
Yeah.
so we will be very proactive about it. And if
Mm-hmm.
you're interested in research, the one thing I want you to do is to reach out to your professor, to your advisor, to the chair, and just talk to us about it. We are very happy to
Mm-hmm.
make sure that you are connected to a research faculty advisor whose research matches with your interests, and to see you progress uh, in your undergraduate research, which will open up several doors. If you
Mm-hmm.
do undergraduate research, you become eligible for these awards to which we nominate you, for internship opportunities, and will give you experiences which are very valuable going ahead. No matter what you do, whether you choose to go for graduate school or enter the workforce,
Mm-hmm.
it's going to be very useful. Um,
Absolutely.
I want to add a few more things. So it's not
Mm-hmm.
only what we are doing right now, but we are also working on collaborations with groups at MIT and also at Harvard on major projects, proposals that we're submitting to the Department of
Mm-hmm.
Energy, to National Science Foundation. And if these efforts are successful, then we would even have funding for undergraduates to do research at places like MIT and Harvard over the summer, basically. So not only do we have plenty of research opportunities now, I think in the future we expect to have many more because of this collaborations we are building with MIT and Harvard on multiple fronts, especially in the fields of quantum information, artificial intelligence, and quantum materials.
Mm-hmm. Wow. And what skills would a prospective major need to come in with in order to succeed in the physics major?
Okay, it's a very good question. So there are, I think, two or three important points. First thing is, as I said, mathematics is the language of physics.
Mm-hmm.
So they need to be comfortable with mathematics. They should not be averse to mathematics, right? Uh, if they aren't as prepared, that's fine. We can help them prepare. But ideally,
Mm-hmm.
we want students coming in who, you know, have some exposure to calculus. I mean, they know they're interested in mathematics. They should be interested in mathematics first of all. They should not be mathematics averse, because many people are fascinated by physics, but they don't want to do the hard mathematical calculations. No, that's not going to be a good recipe for success. So you need to be this that okay. The second thing is you need to be curious. Curious about
Yeah.
how things work. So if you're curious about how things work, and you're interested in learning deep concepts which have many interdisciplinary applications, and you are comfortable with mathematics, you're comfortable using mathematics, you enjoy mathematics because which is the language of physics, uh, having also some inclination towards programming, to be able to
Mm-hmm.
work with computers, use Mathematica, MATLAB, some of these easier to use programs, would be a bonus. So yeah,
Mm-hmm.
if you're the prime thing is you must be curious about how things work, and you must be willing to then think hard about it. That should be
Mm-hmm.
a driving force. And then even if you're curious, you should also be technically prepared, which means having the mathematical background. The physics intuition can come, we will teach you that, and mathematics also
Mm-hmm.
will teach you, but you need to have some basic level already
Yeah.
uh, in order to succeed.
Mm-hmm. And then my final question for you is, what is your favorite thing about the field or that you've done in your own career?
Okay. Yeah. So I think one of my favorite things is how learning some deep ideas in physics sheds
Mm-hmm.
light on seemingly unrelated problems in other disciplines, which you can solve. So and I've used this to solve different problems. So
Mm-hmm.
for example, something that I'm working on right now is um, I'm looking at the physics or statistical physics of rare events. Okay, that's something that we study in non-equilibrium statistical physics. So these
Mm-hmm.
theories that were developed there, I was able to use those ideas and the concepts there to solve problems in very diverse areas. In one problem I'm working on is actually a problem in AI, artificial intelligence. So, computer scientists were looking at ways of, in fact, so everybody's heard of Chat GPT, right? What makes
Mm-hmm.
Chat GPT special is that it not only does it have language processing, but it also has a program called reinforcement learning inside it, which sort of tries to learn a reward function for
Mm-hmm.
how to give right answers. So it doesn't know what the reward function is, it learns it using a idea
Mm-hmm.
called reinforcement learning. This is one of the key pillars of machine learning, which makes artificial
Mm-hmm.
intelligence special. So there is a lot of interest now in understanding reinforcement learning, this approach towards AI, one of these machine learning approaches that is key for AI.
Yeah.
So it turns out that there's a version of this reinforcement learning called entropy regularized reinforcement learning. And what we realized was that the problems that people consider there are very similar to problems that physicists consider in the physics of rare events. Okay, but then the machinery that's developed in physics can actually be used to develop new approaches for AI and solve open problems in AI. So to me, that was very fascinating because we build a bridge between physics, a mapping between physics and AI research. So now with this, what happens is that we can use ideas from physics to advance AI research. But it goes both ways because we can also use new tools from AI to solve problems in physics, right? So when you have this kind of a connection between different disciplines that are previously unconnected, it opens many new doors for you. It opens, allows you to sort of see things from a different perspective. We can see like problems in computer science and AI from a physics perspective, and we can also use new tools that have been developed to solve, difficult physics problems. So this kind of a building bridges between different disciplines using concepts from physics is something that I find very, enjoyable and interesting, seeing the connections. And it happens because physics is deep and foundational. So, if you understand that, then the concepts that you understand are applicable also to other cases. And I think this is also very important for current research because what is happening is that research is progressing on so many fronts. It's becoming very specialized. It's very difficult, even for the most accomplished scientists, to be fully aware of what's going on in different fields of even within mathematics, within physics. You only know your subfield basically. You only know it's very difficult to know what's really at the forefront. But in physics, you know all the big ideas. So if you know something very well and it's a deep idea, you can use it to advance other fields, which the connections have not been made. So there's a lot of opportunity now, especially now, I think, with so many disciplines being so mature, to actually do some cross fertilization of ideas where you use concepts and equations one as long as you can see the connection. So so a lot of opportunities, a lot of this there, and that's something I enjoy very much. And that's something I've done over my career, and I've enjoyed. Yeah.